Using the principle of the conservation of mechanical energy, show that the acceleration a of a freely falling body has the value g. Mechanical energy conservation just means that mechanical energy is a constant quantity that does not vary with time, meaning that its time derivative is equal to zero. On the other hand, free fall means that the only force that acts on the body is the gravitational force. In order to visualize the motion, we are going to draw a free body diagram of this scenario where we have the ground, and we're going to draw the free body at a given height x relative to the reference ground. Now this body can have any kind of velocity. It can be going upwards, downwards, or have no initial velocity whatsoever. It does not matter. Obviously, we're going to take that the gravity is pointing downwards towards the ground. Now the mechanical energy of a system is equal to the sum of its kinetic and potential energy. And the kinetic energy of the system is equal to half mv squared, while the potential energy is equal to mgx. Now we're going to use the fact that the derivative of mechanical energy with respect to time is equal to 0. And then we're going to use the fact that the derivative is a linear operator, so we can distribute the derivative on the two different terms. So we'll have one that is the kinetic energy and the other term is the potential energy. We can also realize that the half m and the mg are constants, and they can therefore be taken out of the derivative. And now we can use the chain rule to derive the velocity squared quantity, and we get that it's equal to half m 2v dv by dt. Now obviously we can simplify the 2's, and we'll have mv dv by dt plus mg dx by dt is equal to 0. Now we need to have this reminder that the derivative of x with respect to time is just the velocity, is just the speed, and the derivative of the velocity with respect to time is just the acceleration. And so we substitute this into the equation, and we get that mv times the acceleration plus mg times the velocity is equal to 0. Now we're going to do some rearrangement, and we get the following equation. We can take mv as a common factor, and we end up with a plus j is equal to 0. mv, obviously in the general case, the mass times the velocity is different than 0, so generally you'll have the acceleration is equal to minus g. The negative sign just means that the acceleration is downwards, because our sign convention was upwards and gravity is always going to be pointing down.